Unveiling the Hidden Dynamics of Earth's Terrain. Tectonic Waves Lift Continents by Satori News. In a groundbreaking study led by the University of Southampton, scientists have provided answers to a long-standing geological puzzle concerning the unexpected rising of continents in areas considered tectonically stable. These monumental research findings offer insight into the natural forces sculpting the Earth's landscapes, particularly its escarpments and plateaus. The phenomenon of towering rock escarpments at the fringe of continental rifts, like those encircling South Africa, has not been entirely inexplicable to geologists. However, the fact that areas far from these rifts, called cratons, which are the oldest and most stable parts of the continental lithosphere, also experience uplift, has posed a vexing question to those studying tectonic plate physics. Southampton's researchers propose an intriguing theory that slow-moving, wave-like forces deep beneath the crust are the culprits for such vertical movement. Utilizing a sophisticated statistical model to monitor surface movements over extensive periods, they have detected how continents react and adapt in the face of rift changes across millennia. The study submits that these long-duration waves in Earth's mantle emanate outward from rifts at a pace of some 15 to 20 kilometers per million years, inciting corresponding crustal surfaces to rise. Over time, this ascent generates inner escarpments and plateau formations in stable continents beyond the rift zones. This upward movement can be likened to the mechanics of a hot air balloon, where the wave-like force on the underlying mantle parallels the weight discharge of a hot air balloon, permitting the lighter crust to ascend and gradually erode into escarpments and plateaus, etching the Earth's surface over geological timescales. The specific case study dealing with the ancient supercontinent Gondwana, which today constitutes massive landmasses including Africa, South America, and others, traces the birth of South Africa's Great Escarpments and Ethiopia's Central Plateau. Such changes owe their existence to a sudden geological upheaval from the Earth's core by a process known as isostasy, accompanied by the removal of deep mantle material that causes the stable continental areas to lighten and begin to rise. Furthermore, it was discovered that rock near continental rifts is prone to faster erosion than that within the stable continental interior. This leads to a retreat of the escarpments from the rift edges, forming steep cliffs and plateaus in their wake. This uplift phenomenon stretched over tens of millions of years, postulating that continental rifts can propagate a sustained wave of surface erosion, thus contributing to the plateau formations as the land continues its ascent. These novel research findings challenge the prevailing assumption in geodynamics that stable continental areas are inert, demonstrating instead their dynamic nature influenced by deep Earth processes. Thank you for choosing Satori News.